In past lessons, we've used the area model to help us keep organized when we're expanding products of binomials. So let's look at an example of this where the factor that we're looking at is actually a repeated factor, such as the product x plus 4 times x plus 4. You can also write that as x plus 4 squared. It's the product of two factors of x plus 4. So either way you see this, we expand it the same way. So if we're using our area model, right, we think about a square that has sides of x plus 4, both sides of the same length. And if we break this into the four regions, right, we are expanding x plus 4 times x plus 4. In this box here, right, we get x times x, which is x squared. In this box, we get 4 times x, which is 4x. And so the product here is going to be the sum of x squared plus 4x plus 4x plus 16. We can combine those like terms. Right, 4x and 4x is 8x. Before we look at the structure of this, I want to show that there's another way to do this. Some students like to think about this as using the distributive property instead. And so sometimes we're just going to talk about using the distributive property to expand these. And so thinking about distributive property here, just think about this as some number that we are distributing across the sum of x plus 4. So we have that number times x, and we have that number times 4. Now from here, we're going to use the distributive property two more times. So we're going to distribute x across the sum x plus 4, and we're going to distribute 4 across the sum x plus 4. So we get x squared plus 4x plus 4x plus 16. You'll see that's identical to what we got down here when we thought about using the area model to organize our thinking. This result is what we call a perfect square trinomial. It's called that because it came from expanding a perfect square. It came from expanding some factor that was being multiplied by itself. Now, if you can recognize the structure of a perfect square trinomial, it becomes relatively easy to factor it. You don't have to do a lot of guess and check of what factors might go in together to give you the trinomial that you're looking for. Notice here at this previous step where we had two identical middle terms. Right? That came because the x and the 4 was repeated in each case. So in both of these boxes, we had a 4 and an x. So those two middle terms are both 4x. You combine them together, you get 8x. So basically, and that, by the way, this 16 is coming from 4 times 4. So this middle term here is 4 plus 4. It's coming from the sum of those two parts of the factor. And the 16 is from 4 times 4. So any trinomial that has this type of structure is going to get factored in a similar way. So consider x squared plus 10x plus 25. If we think about numbers that give us 25, one of the sets of options that could multiply and give us 25 is 5 times 5. 25 is a perfect square. And if you look at this middle term here, it would be the sum of 5 plus 5. It's twice as large as that factor, perfect square, the factor of the perfect square of 25. This is a perfect square trinomial also. It had to come from essentially taking the square root of that first term, x, the square root of the last term, which was 5. We need 5 plus 5. We need a positive 10 here, so we're adding here. So this came from x plus 5 times x plus 5, right? We can double check. X squared, 5x, 5x, 25. So again, that middle term is 2 times 5. It's the sum of those two 5s, right? Then the final term, 25, is 5 times 5. So what you're looking for to identify perfect square trinomials is, first of all, you need a perfect square as the final term. And whatever the square root of that is, if you take two factors of that and add them together, if that gives you the middle term, then this is a perfect square trinomial. So looking at a couple more examples of where you're going to see that. So let's say x squared plus 20x plus 100. Right? 100 is a perfect square. It's 10 times 10. The middle term here, 20, is 10 plus 10. So when we factor this, it's going to be x plus 10 times x plus 10, or we can write that as x plus 10 squared. Feel free to verify that. Draw out your chart. Make sure that when you multiply x plus 10 times x plus 10, you get back to x squared plus 20x plus 100. One final comment here is that you could have a negative middle term. So for example, x squared minus 10x plus 25. Again, square root of 25 here. This is coming from 5 times 5. However, we need a negative 10 for the middle term. So rather than being positive 5 and positive 5, we're actually using negative 5 and negative 5 as our factors here. We still, negative 5 squared is 25. Negative 5 plus negative 5 gives us the negative 10. So when we factor this, we're going to get x minus 5 times x minus 5 instead of x plus 5 and x plus 5, or x minus 5 squared. And so if that middle term is negative with what otherwise looks like a perfect square trinomial, that just means that the factors you're using here for the last term are the negative of the square root rather than the positive. Just to kind of show you that this works, right, if we use our area model to organize our thinking, double check that x minus 5 times x minus 5 does indeed give us what we're looking for. All right, so we have x squared minus 5x plus 25. Combine your like terms, and we get back to where we started. So one more quick example of that, to again kind of mirror the previous example we did when we had x squared plus 20x plus 100. We saw that was a perfect square trinomial. That factored as x plus 10 times x plus 10, or x plus 10 squared. If instead we have x squared minus 20x plus 100, so again 100 here is a perfect square, it's 10 times 10. 10 plus 10 gives us 20, but we need negative 20. So we need these two factors here to be negative 10. So the negative 10 plus negative 10 gives us that middle term. And so this one factored is x minus 10 squared.